Hello, my name is Shobna Fletcher. I'm a maths graduate, previously head of maths at a general further education college and regional maths lead for the Centre for Excellence programme, otherwise known as CfEM. This is a short video to introduce the ratio table intervention. When CfEM first started, there was a consultation with the sector which led to the development of 5 key principles of mastery teaching in further education. These are listed for you to read. This intervention touches on each of the 5 key principles, but principles 1, 3, and 4 are the most pertinent. A ratio table helps uncover the mathematical structure, and the ratio table can be used for many different areas of the curriculum and helps to understand proportionality. Action research findings over the past 3 years have led to the emergence of 3 key questions. Take a moment to have a look at those questions inside the 3 circles. It's the question in the green circle, which is the keenest focus for this intervention. But as you will hear in the video, the blue circle of responsiveness and the red circle of engagement and resilience are also a key part to this approach. The intervention is being run by a CfEM college that I've been working with over the last 3 years, Leighton Sixth Form College, and is being led by their excellent centre lead, Byron Sheffield. Later in the video, you will also hear from Catherine Cockerton from Western College, who's been working with the ratio table for now over 2 years. I'm going to hand over to Byron, who will provide some background for you.
Hello, I'm Byron Sheffield, and I'm a CfEM Centre Lead for Leighton Sixth Form College. And I would like to welcome you to an introduction to the intervention for ratio tables. Proportional relationships are all around us in the world, and when students learn about them and start to recognise them, they will have a new mathematical lens to use in their lives. The idea of proportionality can be challenging for students because they often have the key misconception of using inappropriate additive strategies in scaling problems, rather than understanding the multiplicative structure. The other thing that we notice from school, particularly for percentages, are the range of algorithms students are expected to apply to mathematics as the same structure. Recognizing when we have a multiplicative structure has been aided by CfEM research in the use of models, particularly the double number line and ratio table. Both are different forms of the same idea, except the double number line has a scale, it's a number line after all, whereas ratio tables are more exploratory and have been found particularly effective when used in a real context, which is relatable for young adults. This intervention will use the ratio tables as a model for multiplicative structure for a variety of topics in your scheme of work: recipes, best buys, unit conversions, and rates of speed. The activities have been designed to help students improve their ability to recognise proportional relationships by giving them the space to think about what they are being asked and to use the ratio table to help them organise their thoughts. There is nothing to buy to carry out this intervention. You just need 2.5 hours teaching time in the month after the November reset. You will find the activities require good listening skills by the teacher to encourage the student to move away from an isolated procedure, whether that be a compound triangle or doubling and halving, and think more about the idea of proportionality. In these activities, it is important to ask the student to relate to the context, and they will be encouraged to think about what is being asked before jumping in to calculations.
Thanks, Byron. So let's take a look at exactly what a ratio table is, because you may have not seen one before. We can all take for granted our understanding of the concept of rate. If £1 is $2, then £5 is $10. Without drawing a straight line graph to show this relationship, we can see it isolated in a table, like two coordinates you'd see in an XY plane. As Byron said, multiplicative reasoning is central to many aspects of mathematical learning and in employment and everyday life. Ratio tables help learners explore the multiplicative relationships working both within and between quantities using processes of division and multiplication. Ratio tables provide an intuitive framework with numbers safely housed in little boxes rather than working sprawled out across a page. This tidy representation of the problem perhaps slows them down at first, but having the numbers in a grid, a ratio table, allows them to hopefully see patterns and for the teacher to address possible misconceptions, which usually arise from additive strategies. Ratio tables also aim to improve resilience for proportional problems, encouraging them to work less procedurally and more flexibly and creatively, finding their own solution. It doesn't help with fluency. The calculations themselves need to be explicitly taught, but it might help the learner find other ways of finding the solution using what they already know. For example, if they cannot divide by 16, they may use a ratio table to divide by 2 4 times. And even with simple problems, you as the teacher are also encouraging them to explain their answers. So if they just tell you the answer, you can prompt them with the word because and ask them to elaborate with the ratio table as a scaffold. Building those reasoning skills is key to problem solving, which they need to be able to pass their GCSE. Aside from the ratio table itself, the other critical success factor is that we do not ask learners to leave common sense at the door. We present problems to them that are real, contexts are real, and prices are real, as at the time of writing the questions. Academically, it's called a realistic mathematics education or RME approach. So the RME approach is very important to the use of the ratio tables in this intervention. So let's quickly show you an example of a simple ratio table, and then I'll hand over to Catherine, who will take you through some of the ones from the intervention. Please take a moment to read the question. Here we've drawn a table to represent the problem. We can either find the saving of one t-shirt, or probably more obvious is to work out the cost of 2 single t-shirts. It does look like a grid of coordinates in an XY plane, but instead of XY, we have variables of pounds sterling and number of t-shirts and their corresponding quantities. Most learners will recognise that they need to double £18.50 and see that horizontal relationship to find £37. But some may not find that vertical multiplicative relationship, which brings you to the same answer. Obviously, this is just a very simple case. So I'm now going to hand over to Catherine, who will give you an outline of the types of questions you will use in this intervention, but full details will be provided in the training.
Hi, my name is Catherine Copperton. I'm an action research lead, so never ever use the triangle anymore because they always get it wrong, or not always, but then they always get muddled up. They've got decimals, so there's so many things that they can risk them to go wrong. I like to be free with the structure to show that I'm literally, it's so easy, we write it out, and they're modeling it is important. So we've got minutes here, just ignoring what's above me a minute, but I'd always do the hours first. So for 1 hour, I'm going at 2.8 miles in 1 hour. So that would be 60 minutes. That's still 2.8. And they're all like, yeah, I get that. You know, they're keen. They really like this sort of thing. 1.4, 30. I'm not saying that all my students are like this, but when we do this lesson, they are. And we've all found that. All our action research teachers found that. They were all engaged in it. And then you can go right down to 15 minutes and even then 5 minutes if they can divide by 3. And then they can start seeing how, oh, yeah, look, it's 90 and things like that. So it really is effective, really effective.
So that's a whistle-stop tour of the ratio table intervention. Just to also add, there'll be a very short pre and post questionnaire and a few GCSE questions to see if this intervention made a difference in just 4 weeks. We are so excited to share our research with you. And finally, to end this video, I'm going to hand over to Byron.
Thank you for listening. We think using a ratio table in a context that is relevant encourages students to recognise proportionality and do the right sums. So let's see if the success of using ratio tables in Leighton and Western colleges can be replicated in other parts of the country. Thank you very much for joining us.